This video is just a quick demo of Linux processes and Linux signals and how to handle them and do some creative things with them in a Python application. So, little breakdown of Linux signals. Essentially, they are ways of the kernel to communicate to a process to do a variety of things. This web page has a list of some of the signals available that the kernel can send to a process. You may have heard of sigkill. This is done to force a process to terminate, but there are many other signals. Another common one is sigint. This is like if you were to press Control C at your terminal you're not actually killing the process in the sense of like using a sigkill, but you're more interrupting the process. And depending on that process and whether or not it's doing any signal handling, that could actually terminate the process, or it could do something else. So there are some caveats here, but let's just do like a quick demo. So over here I have an Ubuntu virtual machine and if I just do like sleep for 60 seconds, right now if we open up another terminal, which I have here, I think, we can do a ps and then grep for sleep, and we can see our process running. This is the process ID. Now if I go over to where sleep is, and let's say I'm done sleeping, I can press Control C, and that will actually terminate the process and bring me back to my bash prompt. And if we go to this other tab and we do that ps command, we don't see our sleep process running because the Control C sent a sigint to the kernel. We sent that message to the kernel, and the kernel interrupted that process, or I guess sent the sigint signal to that process, and it terminated it. Okay. So we could have done the same thing if we run this again, and we in our another tab we find that process ID. We could also use the kill command. So we could say kill dash, you could do dash dash signal sigint. You could also just do dash sigint, different ways you could write it, and then the process ID number, which is this. So if we send this kill command, sending a interruption signal to this process ID, we press enter, switch over to the other tab, we can see we're no longer sleeping, we're back at our prompt. So we just did the same thing, essentially sending a sig interrupt to the sleep process, just from a different terminal window. Alright, so maybe you've ran into that when programs are running slow and you just need to terminate it. But sometimes things can get hung up. So what I want to show now is a Python program. And this program is pretty small. Forgot how to show line numbers in Vim, but anyways, 30 lines or so. Have some imports here. This is the key thing. So our main program is just an infinite loop that prints out a string. It says application is running with the process ID. And then we sleep for 2 seconds, loop back up, and that just goes on and on and on. Now here's the interesting thing. So Python has a library, part of the standard library, there's this signal module. And I opened it up over here, and you can read the documentation about it. You could just search for Python signal. But what we're going to look at now here is this signal.signal function. It takes a signal number, which is one of the available signals for the operating system, these types of things, and then a handler. So essentially a callable function that you can handle the signal. So the way we're using this here is that we just have a few different handlers. So we have a sig_int handler, just printing out got a sig_int. We have a sig_hangup or hup. That's another type of signal. So you could do something different there, like this says reloading config, and then a sig_term, which does the same thing. So essentially, I'm just trying to portray that you can have functions, and we're just printing stuff, but you could do whatever you can do in Python within these functions, and then these are passed as the handlers to signal.signal. So we're saying for sig_int, call the handle sig_int function. For sig_hup, call the sig_hup handler, etc. So that's all we're doing. So let's go ahead and we'll close out of this and then run our app. So we're in that infinite loop. It's just printing out that our application is running. Here's the process ID. So if we switch over to the other terminal, do a psaux, and we'll grep for Python, we can see our main.py process is running 54569 right there. All right, so now let's try to kill this process. So previously when we did sleep for 60 and we did control C, it terminated the process. So I'm just going to do a control C right now. And we can see that I pressed control C and the process is still running, and we see that got a sig_int, but I'm not stopping. So that is coming from our sig_int handler. So it doesn't actually terminate the process. We can do this PS again. We see it's still running, same process ID. So we've handled the sig_int signal. Now, let's do a sig_hup. So from the other terminal, I'm going to do a kill on this process, and I'm going to do --signal sig_hup. So this is just a different type of signal. Whoops. I can just do --sig_hup. And then if we switch over, we can see we handled that signal. Reloading config, so it called the handler. The other one we have is a sig_term. And then we run that kill command. We see we got a sig_term, exiting gracefully, etc. So that's just showing how we can use the signal module from the Python standard library to create these signal handling features. Now, I just instinctively tried to press Control C to kill this process, but we're handling the sig_int, so that's not going to work. So what I'm going to need to do to kill that is to hop over to this other terminal, and I'm not going to do a sig_int. I'm not even going to do a sig_term, but I'm going to do a sig_kill. So sig_kill is a unique signal in that you cannot, a process cannot handle that. It's kind of like a forceful killing of the process. So this is also kill -9, same thing. Every symbol, so like sig_kill, will have a number associated with it. But I'm going to do a sig_kill, and that will forcefully kill the process. And you can see it's killed. That's kind of the signature that it was killed with the sig_kill. So you might be wondering, like, can we handle a sig_kill? I mean, I just said that kill is unique in the way that they can't be interrupted, but we can try it. So if we go here and we'll just say like def handle sig_kill, we'll use the same signature, got a sig kill. And then we need to register it down here. So I'll just add another call to signal.signal. Gonna handle sig kill, and we'll pass it to the sig kill handler. So I'll go ahead and save this, and then we'll run the app again, and we get an exception. So we get an OS error, an invalid argument. So this is actually the Python signal library is saying, hey, you can't interrupt a sig kill. That's just a law. The kernel will not allow that. So it doesn't even let you run the program. So that's pretty cool. Now let's delete that. So we know that we can't interrupt a sig kill or a kill -9. So yeah, that's just kind of, kind of a fun little thing to play around with. I'm trying to think of like a more real world use case for this, but let's say you got like maybe you're running like some logging shipper, and when that logging process might get a sig term, and instead of just forcefully terminating the process, maybe you need to do something like like flush log records, and then do a like sys.exit instead of just hitting sys.exit, or instead of just terminating the process abruptly. You can actually do your maybe like final flush of your log records or something like that. And then you can even wrap this around a timeout if you want, some type of logic like that, where that's where this term kind of like graceful shutdown may have originated, is like handling signals and then kind of cleaning up before you exit. Anyways, that's just a little demo, a little bit about Linux kernel, Linux signals, processes, and how to play around with them using Python.